And sonar. Sonar is equipment. And there is a equation for sonar. Speed of sound is different for different material. And sound propagation in ocean is important in application systems. So this is sound level decibel scale, and I know that this is a logarithmic scale, so it's not linear or anyway. Reading leaves and whisper, rainfall, refrigerator, conversation, car, city, truck, hairdryer, helicopter, trombone, police siren, jet engine, and firework. So you can. So this is a sound pressure. Sound is a mechanical wave that is the oscillation of pressure transmitted through medium, solid, liquid, and gas, which is detected by a receiver as a changes in pressure. So your ear senses the pressure changes. That's how sound is detected. Acoustics is such as a science or academic field or engineering field that deals with sound and sound production, sound control, sound transmission, reception, effect. So once again, it's same picture but a little bit different. Starting from here, going up, and this is sound pressure. This is decibel. It's same, but different unit. Underwater, that is our main focus. This is Leonardo da Vinci in 15th century. Ship. If you stop your ship and place the head of a long tube in the water, and listen to using your ear to the tube, then you can hear ships at a great distance from you. So sound from far away, some noise can be catched through the underwater tubes. But he already knows about this phenomenon. So application area of this underwater acoustics was the sonar. Sonar is a short name for an underwater communication using sound, and localization and navigation. Localization is pinpointing, where is it? So position, finding position, localization. Where am I, or where is the enemy? That is localization. By using sonar. This is very similar to radar, right? Radar. But based on different technology or so sonar is very similar to radar, but they use only sonar. Sound. Then radar is electromagnetic waves used. This is also wave, the sound wave, with different element. And seismic exploration for finding out something, especially nowadays in trying to find out oil reservoir and gas reservoir. They use also sounding methods. By sending sound and returning back sound, they can expect. You may know or may not know about the ultrasound medical imaging system. When you're already married, baby inside, right? What is it? 산부인과 입국.
범신.
Say again. Obgyn. Anyway, the medical doctor for baby, and they use Also for the other purpose for medical inspection, they use ultrasound devices. So it's similar, not same, but similar. To see what is inside by using sound, ultrasound. So that is more bigger scale, right? Earth, inside Earth, or body inside the body, right? Using sound reflection, you figure out what is inside. So this one is a survey ship, and then they send a shock wave using air gun substance. Bang, bang, right? And the sound is going down and reflect. So there is a series of receivers called a series of hydrophones. And this is a seabed. The soil starts here. The sound probably reflects mostly from here, but some of them is going down, and reflects differently. Right? So this one can be very vague, low-level reflection. Right? But anyway, they have a technology to see the differences between reflections because of the soil and rocks, and also in conformity, and then also oil and water and gas also. So using this different pattern of sound, they can figure out, very similar to your body, right? Reflected sound is different, so they know how to treat them and figure out making a picture of it. And sonar works. Sonar use sound echoes to locate object, as does radar. Very similar to radar. Sound sending an object and reflected wave, and using this reflection, the same as bed or floating or and also submarines. Why sonar? Why do not use radar inside a submarine? Because radar is more clear. Because the electromagnetic propagation is not going well inside the water. That is the reason. Sound is not good as much as the electromagnetic wave. Not clear. You know about this one because of the radio. There's AM, FM, and then we also use very high frequency electromagnetic wave for this one. So each one has different advantage and disadvantage. So low frequency is used for AM radio. FM is more high frequency. Right? So FM is more clear, and they can deliver more data, similar to this one. But problem is the distance of travel. So sound is more lower side. So it travels good distance, but quality is not. So this is losses and attenuation. We cannot use, cost too much. There is a technical picture on liquid water, red line, and blue line is ice, very similar. They have a very similar pattern. This is probably length of wave, something. And this is a level of, there's no exploration. Observation spectrum. So probably observation coefficient, something, attenuation coefficient. Anyway, this one is probably less because Bay4 has a mixture of air and water. So attenuation can be lower than what? Communication. So still, we can use 3 types of electromagnetic or optical, but best one is acoustics because of the previous reason. So this is a submarine, and this is probably can be enemy or can be our navy. So depending on situation, very similar to previous one, the sound source or shock wave is coming, sending, and returning back. There is a receivers, array of receivers, many of them, because returning back can be spread out. So you need to have a more receivers. Single source is okay, but receiver should be also array. Electromagnetic wave, as told before, the communication can be at higher frequency and bandwidth. Bandwidth means data volume bandwidth. So they can send more data per second. But limitation is due to observation or attenuation. So they cannot use. If you want to use this one, you need to have a very big antenna. Also, any very frequent antennas, many antennas, short distance. Say this data APs should be very near and many, right? Because they use very high frequency waves. So comparing to the radio station. Radio station is far away. You cannot see where is the radio station. Very far away. Affect the design complexity and cost. So that is the main reason. And similarly, optical waves also similar can be used with the high data rate transmission. The bandwidth is good, but the signal is not good in what the scattering effect. So that's why we use. And then the sound speed in different material. We know that air, supersonic airplane is about this meter per second. For water, it is about 4 times higher, more than 4 times. And in metals, this is much more. So still doubling or 4 times higher than water. So because of the density of the material, speed is going higher. Acoustic wave is the most preferred signal used as a carrier by application oriented low absorption and the communication. But the data transmission is slower. Bandwidth is small, comparing to the electromagnetic wave. So, but it is travel longer range, as I told you before. So there is an active sonar and passive sonar. Active including the light emitting. See that this bulb is very small, so that the light is coming more parallel than comparing the point source of light. This is the same picture. The point source of light that gives you a spreading out, but cylindrical spreading. Then there can be a very also the density, energy density or light density can be higher here for you. This is you can calculate the level of right? And sound source and noise in shipbuilding or something. And for the, say, submarine, so because the enemy submarine, I heard that China submarine has a very high level noise, so that is not good for them. But where is the source of noise coming from? Submarine, it can be a machinery and also flow noise. And fouling can be the skin of the ship. Skin of the ship. If the skin is very clean, that then sound can be lower level. But if skin is not clear, it is dirty or something attached with shells and something, then it can create more noise. That is, we say, fouling. And cavitation. Cavitation is something like a boiling of the water. When you may not have the experience, but we know that if we go up to the high mountain, say Himalaya, something 3,000 or 8,000 meters, the boiling temperature is lower than 100, right? Because pressure is lower. Pressure means the weight of the air there. Right? So weight of air is lower, higher here. Right? So that's why boiling is earlier than 100 degree. And cavitation is same. So in underwater, the temperature can be, say, 10 degrees Celsius or 15 degrees Celsius. But pressure is very low, then it can create bubbles, same as boiling. That is the cavity created by low pressure. But it's a local, not everywhere. Local phenomena, some place of the propeller, and then speed of the water or rotation is higher than the other place, then it can create bubbles. Sometimes, not always, sometimes. But the problem is the creation is okay. Creation is no making no big sound, but collapsing of it. Collapsing of a bubble can create a big sound. That is the main reason for cavitation problem. Propeller is rotating, so the speed of and the pressure levels are different when rotating. Each position here, 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 pressure level is different because the water inflow is different. That's why this position they create a bubble, but when going down is collapse and generate and collapse and generate and collapse. This is the way the noise is coming. Cavitation noise. Ambient noise is just coming from outside, so it is not generate noise. It is outside noise. Different the other ships biological. Oh, this is a spectrum level in something. Earthquake, biological precipitation is some raining, ship, and then sea ice. And what is this? Numbers. Seismic, ocean traffic, bubbles and spray and molecular agitation. So there can be a low level and frequency, decibel. So this is a high sound, big sound. Yeah. So in ocean there is a different kind of sound sources. Oh, this one. Yeah. Oh, this is the final slide. Good.
You're diving in the ocean when suddenly a large military submarine sails next to you. Question: how can this vehicle harm you? Well, the possibilities are endless, but the one way you probably didn't think of was sonar. Sonar is an acronym that stands for Sound.
Because like the
Sound is
from
good.
the laptop from
Sonar is used because sound waves travel through water much better than
originally no sound.
in submarines, especially military
시작하실 때도 특급 사운드를 끄셨던 거예요.
이걸 꺼서부터
variants typically do not have windows. Sonar is a submerged submarine's eyes. There are two types of sonar, active and passive. Passive sonar simply listens to the sound of the water. It listens for marine life and other ships that may be nearby or using active sonar. Active sonar, on the other hand, actively sends out pulses of sound and listens for how long they take to return when they bounce off an object. Sonar works by calculating the echoes. Once you know the speed of sound in water and the time it takes for the signal to return, you can determine an object's distance. And this is a type of sonar that could potentially harm you if you were diving next to a submarine for some reason. So, how can it harm you? Well, sonar is a sound, a very loud sound. A sonar ping can be as loud as 235 decibels. To put that into perspective, the loudest sound you can hear before your eardrums rip apart is about 160 decibels. Above 194 decibels, sound waves become classified as shock waves in the air. In water, however, sound can get much louder. Getting hit by a 235 decibel sound ping will likely burst your lungs and cause your brain to hemorrhage, which in most cases will kill you. But if you're lucky enough to survive, you're probably not going to be in great condition. What about bats? Bats also use sonar and they don't burst lungs or hemorrhage brains. Well, the reason for that is simple. Bats are not submarines. More specifically, bat sound frequencies are in the ultrasonic, ranging from 20 to 200 kHz. Human hearing tops out at 20 kHz. These sounds can reach up to 120 decibels, but since they're ultrasonic, we can't hear them. Scare tactics aside, it's unlikely that a submarine will use its sonar to casually distress a swimmer, as a sonar ping works both ways. It helps you find things, but it also helps things find you. A submarine's biggest advantage is its stealth, and using what is equivalent to a massive beacon is a bit counterproductive to this goal. On top of that, ships aren't really allowed to use sonar within 12 nautical miles of the coastline to avoid damage to marine life, which includes swimmers. If these ships detect marine life of any kind, they have to turn their active sonar down or completely off. So perhaps submarines are not your biggest threat in the ocean.
Right. My sound is fine. Okay, this is the final slide for me. So we can move on to any questions? No question, then we can move on to second part.